Doug here. So in the collection today, I have a solar radiometer or a solar radiation recorder. Well, this fascinating piece of kit came back from the analog days. There's nothing digital about this, and it's able to record solar output or light intensity. How does it do that? I was intrigued, and I'm sure you are too. First thing I noticed when I looked at the top, saw some black and white strips inside, which got me very curious what's going on. I don't even remember those little science toys, those little pyrometer bulbs that had the black and white vanes that would spin based on light output. I was curious if it operated on the same principle. Well, let's take a look inside. Let's open the latch. We'll swing it open. The lid itself I found is tin and brass that looks to be brazed together. So we'll swing that up out of the way here. Look at those insides. This thing's a work of art. I mean, beautiful machining inside. It's all nickel plated. So here's some theory how I think it works. So you remove the little ink holder from its holster there, and you slowly slide this in to allow it to make contact with the drum. In the back, you pull out the ink dropper and you put a drop of ink into the little bucket here that would allow the ink to flow onto the surface of the drum. This drum here would have an index scale that would wrap around it. We'll get to that in a moment. I was more curious how this worked. So you can see here how the needle moves up and down. This is solar input. So what we have across here are 4 bimetallic strips. And by bimetallic, I mean you have a different material on the bottom than the top, and they're bonded together. So when heat hits it, they'll expand at different rates and will cause the metal to flex in one direction. So imagine these white ones on the front here, they'll flex up as they get hotter, and those black ones in the back will flex down as they get hotter. Well, these ones, there's a fixed pivot on the white on this side, and then they're bonded to the black on this side, and then the black on this end is free floating to the needle. So as the white flexes up and the black flexes down, they'll cancel each other based on the temperature so the endpoint won't move. So ambient temperature is not affected. It's negated in the system. The black here, because it is black and not white, absorbs more of the infrared solar radiation, causing it to bend more than the white ones. So it only records the solar output and not irrelevant of the ambient temperature in the room. A genius system. So that goes down through linkages into the little needle here, which causes it to record. Other item of note inside is this glass beaker that says silica gel on it. This is a desiccant. These are little pellets that absorb moisture. This is something that's really good to keep around your house whenever you drop your cell phone in the toilet or something. That will absorb the moisture better than any rice. So keep those around. Those are the little do not eat packs that come in packages when you buy electronics because they don't want moisture in there. And this is a sealed item. You see this rubber gasket here, and that seals off any moisture from in here because this is paper on here. You don't want it getting wet and moldy because it records for long periods of time. Speaking of, I decided to pull this little drum off here. I noticed on the top here it said 17 days DC 1.5 volt. Well, that had me curious. So I opened it up and I noticed inside here there is a motor and a holder for 2 C batteries. So you put 2 batteries in here, you lock them in with the little set screws, and this motor starts running, and then this disc just slowly rotates. Now, I noticed it's currently set for 1 day, so it will rotate 1 revolution every day. Well, I noticed on the front here it says 1/7. Well, then I figured it out. Once I took it apart, on the bottom there's a spot for a second gear. And if I take this little holster off, there's another gear in here that allows you to set it for 7 days. So it'll do 1 revolution every 7 days, which is a really cool system, depending if you want to do a week's worth of recording at lower resolution or 1 day's worth of recording at higher resolution, depending on what you're trying to measure. And then it has this little bronze holder that goes over top of it. I gotta pull the needle back here. It goes on there, and the needle gets rested in here for transport when you're not using it. And then the last little thing is that little guy in the middle there. That is a spirit level, and you use these little adjustment feet to dial it into perfectly level so everything is true and balanced and you have it all calibrated. This particular instrument is made by the Weather Measurement Corporation. It is a solar radiation recorder, model R401. That happens to be serial number 332. And down here it has the calibration formula for doing the calibration. There's a small set screw down here to allow you to adjust it, and you can align the 0 to get everything lined up to the light output that where you want 0 or baseline to be. So this is a beautiful example of a solar radiation detector. On the drum, once you have your paper on there and recording, you have this little sealed window. You can look in and see your recordings to make sure they're working without disturbing it. It has a little latch on the side here to seal it up and get it going. Now, plans for this project, I'm going to fully tear it down and do a full restore on it. As you can see, it's lived kind of a rough life. It's going to get repainted, refinished, glass polished up, all the hardware polished, and it'll be a beautiful example to have in the collection. The history of this guy, I traced it back to WPXI. It was one of the original weather recording instruments they used for doing their weather broadcasts. It sat on the roof of one of their buildings and lived a long life doing that, which I think is awesome. This happens to be number 11, I'm guessing. So it's got a really cool history and a really cool addition to the collection. Thanks for watching.